Okay, got my. We're on air. Okay, I've got my other thing recording. Let's go ahead and look at exercise 9. Let's just go ahead and get that started. Okay, so here we go. In the picture above, what force is propelling the runner to the right? We talked a lot about that. Okay, Felix Baumgartner was at 828,000 feet. How many kilometers in the air is that? You can figure that out. Now, don't forget we're talking kilometers, not meters. So when you get your meters, divide by 1,000. Okay. How high is the edge of space? I forgot. I think I forgot to point this out. Now, we know how many kilometers he is in the air. I think because that's ballpark 30,000 kilometers. So he's about 30 kilometers in the air. But at the edge of space, where meteors burn up, um, in other words, he's not to the top of our atmosphere yet, but he's way up there where it's very, very thin, and he exceeds the speed of sound when he's coming down. That's for darn sure. Is this true, or is there a thing called drag? All right. Anyway, which of the following characteristics of kinetic friction? There's a slide in the whole drag and friction thing that explains those. A sled and musher have combined. What is the normal for? Okay, so now we're going to look at a sled and a musher, and I'll probably get through these programs or problems, and then we'll save and go on to and then start another one. Okay. All right. So this is homework help 1. All right. So here's what we got. What's the normal force exerted on? Now we talked about this earlier. We got some earlier notes on that. So I've got a sled here. Okay. Here's a sled. Well, actually, the sleds look like this. Let me do it this way. Whoops. Answers are good. I made up a bogus test that had bad answers on it, so using that paper. Bad key. All right. Anyway, so actually, the mushing sleds kind of look like this. And then they got the runners down here, and the person stands back here, like. So here's the person wearing their stocking hat, flowing back like this. They're holding the reins to the dog. It's over here. There's their hands holding the reins to the dog. And then they're kind of bracing themselves here on this sled with the runners here going like this. All right. Oh, hey, that's not bad. Mushing sled, force pulling this way. And here's our little dog. Here's his tail. He's running along. All right, looks like Mr. Peabody. If you guys remember Peabody and Sherman. All right, anyway, got the dog running along. As they said in what I didn't require you to watch those things, but they did say, hey, um, they'll breed those dogs. They're not pure huskies that we'd buy here, that we'd get here for us recreation for us pet owners. They breed them to be fast. Okay, but it's got a weight, and it's on the ice, and it's on the snow, so it's got a weight coming down here, and it's got a normal force that's pushing up on it. Okay, so the normal force is basically, as long as we're going to stay flat, is equal to the weight. All right, so if it's 250, and we know that G is equal to 9.8 meters per second squared, right? All right, so you can calculate that. Now, let's go on to the next couple problems. If the coefficient of static friction between the snow and the runner of the sled is 0.14, how much force is required by a team of 5 dogs to get the sled to move? Okay, I'm not going to draw 5 dogs, sorry. And you don't want to sit there and watch that. But anyway, so what are we doing here? What are you talking about, Woo? As Al Swearinger would say in Deadwood. Okay, it's the coefficient of static friction. So what does that look like? Coefficient of static friction, mu of s. So 0.14. It's a unitless thing derived through experiments. the force of static friction is equal to mu of s times that normal force. That's the maximum force. That's the force that is needed to finally get that thing to move. Whoops. Okay. Is the coefficient, okay, once the sled is moving, the force required to move the sled drops to 250 newtons. Okay. So you determine the coefficient of kinetic friction. All right, so let's do that real quick. What problem is that? What problem number? This is problem 8. This is problem 7. Oh, sorry. So this is problem 7 up here. And this is problem 8. Now, this force right here that's pulling the sled has dropped to 250 newtons. Okay? It's dropped to 250 newtons. So that 250 newtons, and it's going at a constant speed. Is that what I say? Because that's important. I'm going to go back and read that.